We're going to continue solving linear equations using the multiplication and addition properties of equality. So this is part 6. Sometimes people refer to these properties as using the golden rule, which means if you add, subtract, multiply, or divide one side of an equation by a non-zero number, you must do the same thing to the other side in order to preserve the equation so that it still has the same solutions. I forgot the y. Okay, so for notation, if I put GR for golden rule, divide by 3, it means I'm going to divide both sides by 3. So as I work through some problems, I'm going to state next to each step on some of these what I'm doing. Okay, so here's an example. 2/3 x equals -8. So we have 2/3 times x, so we would want to multiply by the reciprocal so that we know what just x is. So I'm going to use the golden rule, multiply both sides by 3/2. So you can see what I'm doing. I'm doing 3/2 times 2/3 x on one side of the equation is the same thing. The golden rule means you have to do the same thing on the other side of the equation. Now, I can write that as -8 or -8 over 1. And let's make that blue. Okay, so on the left-hand side, the reason you multiplied by the 3/2 is so both the 2 would cancel and the 3's would cancel, giving me 1x, which is the same thing as x, because 1 times x is x. Now over here, the answer is going to be negative because you're multiplying a positive times a negative. And let's see, the 2 goes into the 8 4 times, so 3 times 4 is 12. Okay, so I use the golden rule of multiplying both sides by 3/2 to solve this equation. The second step was I canceled. I just simplified. By canceling. All right, let's go ahead and check this problem. All right, remember you just write down the problem, underline it, put a T, and we're going to plug in -12 for x, so 2/3 times -12, so I'm going to write that as -12 over 1, and we go ahead and simplify. 3 goes into 12 4 times, so I have 2 times -4, which is -8 over 1, which is just -8. You could take 1 or 2 steps to write that. You could put -8 over 1 and then do it. On the right-hand side, there was nothing to do, so I just write the number down again. So this means the correct solution is -12. So you could just write, okay, the answer is -12. Okay? Or if you want, you could put it in braces. The only reason I'm writing a box around it is so like somebody can find where on the page you're finally putting the answer. All right, here's another example. X divided by 13 equals -4. Now, there are a couple ways you can think about this problem. You could think of this as x divided by 13, so to undo it, I want to multiply by 13. But whatever you do on one side, you must do on the other side. So I'm using the golden rule of multiplying both sides by 13. Okay, now some people might think of x divided by 13 as 1/13 times x. See how that would give you the same answer? Or the same original equation? But you would still do exactly the same thing. The reciprocal of 1/13 would be multiplied by 13. So somebody else may write it as 1/13 times x before they multiply by 13. But in any case, you're using exactly the same thing, the golden rule times 13. So we can cancel the 13's. The idea is that we want to know exactly what x is, just 1x, and then -4 times 13 is -52. So it looks like that's the answer. Let's check. So the original problem, x over 13 equals -4, and we're going to put in -52 for x and divide, and that is -4. You could do that with a calculator, or I always remember 4 times 13 is 52. I think of 8 deck of cards. All right, so that's correct. So that means the actual answer is correct. -52 is the answer, or if you want, you could use it in solution braces. For this one, we have n over 4 minus 1 equals negative 7. So the variable part here is the n over 4. There's two ways you could work through this problem. One is to first isolate the n divided by 4 by adding 1 to both sides. So I'm going to do that. The golden rule of just adding 1 to both sides. So if I add 1 here, I have to also add it on the other side, and basically you want to line it up under its like term. So on this side I only have n over 4 left on this side. And on the right hand side, be careful, it's negative 7 plus 1, which is negative 6. Now we're back to n divided by 4. To undo that, you want to multiply both sides by 4. Okay, so now you're using the golden rule of multiplying both sides by 4. So we've got n, because the 4's cancel, right? So we have n equals negative 24. All right. I'm going to go ahead and check this and then show you an alternate way of doing the same problem. So the check is n over 4 minus 1 equals negative 7. We're going to put in a negative 24 for n. So that's a negative 6 minus 1. Negative 6 minus 1 is negative 6 plus negative 1, or negative 7. So it checks, so that would be the right answer. Okay, so hopefully you got the golden rule. I'm going to erase that, show you a different way to do the exact same problem, side by side here. Anytime you have fractions at all in a problem, you could multiply both sides of the equation by the least common denominator to eliminate the fractions. So there's only one denominator, 4, so that's the least common denominator. So I'm going to multiply both sides by 4. So my golden rule here is I'm multiplying both sides by 4. So whatever you do to one side, and remember, on the left, the one side is all of this, n over 4 minus 1. So now we need to do the distributive property. So I need to distribute my 4 here. So I have 4 times n over 4 minus 4 times 1. And on the right hand, I have 4 times negative 7, which is negative 28. So what happened here, and the reason you multiply by the least common denominators, is these 4's cancel so that you won't have a fraction anymore. So you have n minus 4 equals negative 28. And now you have n minus something. To undo that, you need to add 4 so that you have n plus 0, which is n, and you would still get n equals negative 24. So notice you got the same answer as when I did it by adding 1 first and then multiplying by 4. So the first way I did it, I added 1, then I multiplied by 4. The second way I did it, I multiplied by 4, and then I ended up adding 4, because once you multiplied by 4, this wasn't a minus 1 anymore, it was a minus 4. So it looks a little bit different. I want to make sure this gets inside so you can see it. So our answer is negative 24. And you could just put a box around that, that's the answer, or again, you could use the braces. Okay, here's another example. 7m plus 6 equals 6. So we want to isolate the variable part, which is the 7m. So we want to get rid of this plus 6 on that side. The trick is to subtract 6 from both sides. So I'm using the golden rule of subtracting 6 from both sides. So this gives me 7m plus 0, which could be written as 7m, and 6 minus 6 is simply 0. All right, so I have 7 times something equals 0. To undo that, I'll have to divide both sides by 7, right? The golden rule of dividing by 7. So I'm going to get m equals 0. All right, and then you could check that. I'm running out of time. Oh, no, I'm not. I've got a little bit of time here. So we're going to check it by, you copy the problem down. And we're going to put in 0 for m. So 7 times 0, doing my order of operations over here, is 0 plus 6, or 6. And on the right-hand side, I also have 6. So it checks. So the answer to this problem is 0. You want to put a box around it, or you could use the solution braces. And if you want, you could put a box around just so it's easy to find the answer. Okay, so go on to the next part, part 7, and we'll just continue doing some more problems. We're just going to keep stepping it up so we have more fractions involved or more distributive property, etc. I hope you learned something. Remember, math is cool.